guys, welcome back. We're going to start with a section today on 1.3 on measuring segments. So first thing we need to do is go over the distance between two segments, or excuse me, between 2 points on a line. So we'll be using this a lot this year is distance, so go ahead and get used to this and how it works. All right, the distance between 2 points on a line is the absolute value of the difference of their coordinates. Well, difference means we need to do some subtraction in here, yeah? All right, now, absolute value. Let's talk about why that's important. Let's say if I'm at A and I need to get to B, it takes me 5 steps. Now, let's say I go backwards. If I go from B to A, is that going to take me a negative 5 steps? No, it's still going to take me 5 steps. So distance has to always be positive, not negative. So we need some absolute values so we know we're always positive. All right, let's look at this question here. Question A, what is UV? Well, first off, let's talk about what is UV. You see how there's not a segment bar? There's not a ray? There's not a line? So what's it talking about? If there's nothing there, it's talking about the distance between them. All right, so I need to know the absolute value of U is located at 10, and then find the difference to V, which is at 14. So 10 minus 14 is a negative 4. And then what we're going to do is do the absolute value of that. So the distance from U to V is 4. All right, what about ST? So S is located at negative 4. And I need to find the difference to T, which is 8. So negative 4 minus 8 is a negative 12. And then absolute value of that gives you a positive 12. All right, so you can also count it. So 2, 4, 6, 8, 10, 12. All right, but if you need to show your work, this is a great way to do that. Next thing up is this good old postulate again. All right, and remember, a postulate is a statement we believe true, even though we don't prove it. All right, so this one is called your segment addition postulate. And it says if you have 3 points, A, B, and C, that are collinear, remember that means they're together on a line, so same line, and B is between A and C, then the length of AB plus the length of BC equals the length of AC. And see if that makes sense. Here's the length of AB, plus we're going to add in the length of BC. Doesn't that make sense? We're going to get the length for AC? Sure. So let's try our segment addition postulate for this segment. Which 2 segments do we need to add together? So our 2 smaller ones. We need the length of EF plus the length of FG, and that will equal the length of EG. All right, so now let's substitute in. The length for EF is 8x minus 14, plus the length of FG is 4x plus 1. So I need to know the length of EG. Well, that's given to us that the length of EG is 59. So let's solve our algebra problem here. Since 8x and 4x are on the same side, I'm going to combine them. 8x plus 4x is a 12x. We have a minus 14 and a plus 1 on the same side. That's a minus 13 equals 59. So next step, I'm going to add 13 to both sides of my equation. And I get 12x equals, when you add 59 and 13, that's 72. Divide both sides by 12, and I get x equals 6, which is great. But you got to make sure you answer your question. This one wants to know what's the length of EF and what's the length of FG. So let's substitute back in. What's 8 times 6 minus 14? Well, 8 times 6 is 48. Minus 14 is 34. And for FG, we have 4 times 6 plus 1. So we have 24 plus 1 is 25 for the length of FG. And always check your work. Let's do our segment addition. 34 plus 25 equals 59, which is what we wanted. Awesome. So we know we've got a good problem there. All right, let's look at our next concept. It's called congruent segments. Alright, congruent segments mean they have to have the same length. Alright, so we've got 2 centimeters here, we got 2 centimeters here. That means that they have the same length, so they are congruent. Now notice your congruent symbol has that lovely little swirly on top, alright? I call it a squiggly. So got a good squiggly. Now, when you talk about segments being congruent, make sure you know you're talking about a segment. So a segment AB and a segment CD. Could lines be congruent or rays be congruent? No, because they go on forever. They don't have a length. All right, so segments can be congruent because they have a length. So we got to make sure we know we're talking about segments. All right, we've got a question. Are segment AC and segment BD congruent? Well, let's find out. All right, I need to know the length of AC. All right, so A is at -2, and I need the difference to C, which is at 5. So -2 minus 5, -7, so our absolute value is 7. All right, I need to know the length for BD. B is at 3, D is at 10. So again, we have a length of 7. So are these guys congruent? Yes, they are. They have the same length. What about, is segment AB congruent to segment DE? So let's look. Let's look for the length of AB. So the length of A, let's see, it goes from -2 to B is at 3. So -2 minus 3 is -5. So our length here is 5. And our length of DE, D is at 10, E is at 14. So the length from 10 to 10 minus 14 is -4. So our length here is 4. Well, these guys don't have the same length. So are they congruent? No, you're not. All right, so those are congruent segments. Awesome. A couple more things about segments is we have a midpoint. Break it down. Mid means, you're right, the middle, and it's a point in the middle. So that means I have 2 congruent segments since M's right smack in the middle. Now notice these fancy schmancy little red lines. These are important. They let you know that your segments are congruent. So I know that segment AM is congruent to segment PM. Now, anytime you have this midpoint, you can have some things that go through it, and those are called segment bisectors. Because we're going to take a segment, bi means 2, sect means to cut, so we're going to cut our segment into 2. Well, we can do that with a couple of things. A line can do it, like this picture. A segment can do it, so just imagine these were endpoints and not arrows. A ray could do it. All right, act like only half of this exists. So there's a ray. Or a plane. So act like there's a plane going all the way around this that will cut that segment in half. Awesome. All right, let's use that vocab word for midpoint. So since I know we have a midpoint, I know that my 2 parts are congruent. So I know that segment PQ is congruent to segment RQ, all because of this word right here, midpoint. Now, my goal is to find the length for PQ, the length for QR, and the length for PR. So let's do some substitution. PQ, I know, is 6x minus 7. RQ is 5x plus 1. Alright, so what I need to do is get my x's on the same side. I'm going to subtract 5x from both sides. Whee! And I get x minus 7 equal sign equals 1. Next up, add 7 to both sides, and x equals 8. Yay! Now, I just have to substitute back in. I need to know 6 times 8 minus 7. Well, 6 times 8 is 48 minus 7 is 41. Alright, so PQ, we've got a 41. QR, we have a 5 times 8 plus 1. So 40 plus 1 is 41. Well, hey, looky there. They're the same thing, and they should be, because these guys have a midpoint, so they should be equal. And let's use our segment addition postulate and know that 41 plus 41, the length of PR, is going to be 82. Awesome, awesomeness. All right, next up, we're going to do another video for measuring angles.